All right. So, shall we begin? Good morning, everyone. Hello, welcome to online. I guess some of you have been online for a while, but now instead of a third of the class at a time, we now have half the class at a time. So it's a much larger percentage, but with you guys, it's still a small class. So I don't know how different it will be, except because I've now got things set up to teach people in person. I'm now standing while on camera, and so this is a little odd for me, but it means I can hide in my desk, and you can't see me dancing awkwardly to the music. That's the main advantage, but otherwise, I'm happy to have you here. Today is going to be fairly straightforward, like I was going to say many Tuesdays, but honestly, with enough shifting around of the schedules, I can't say that for sure. Because some days we'll be on the first half of our section, and some Tuesdays we'll be on the second half of our section. But I've got two things lined up in store for you. One, we'll go over answers to yesterday's worksheet, as usual. And then two, we will have our reading quizzes covering the sections. And I've moved the quizzes to Tuesdays because Tuesdays will consistently be our online session. So that means you guys get the brunt of the quizzes there, and that just allows me to maximize the usage of the in-person time, because we can always retake the quizzes online later time, right? So you've got that to look forward to, and then the rest of the class you can spend working on the remaining practice worksheet, okay? So with that out of the way, any questions about that stuff? New schedule and everything. You guys are not as confusing as the freshmen. That schedule is, oof. Glad I don't have it. All right. So then, without further ado, please take out your worksheet from yesterday. The 13.1 intervention sheet on right triangle trigonometry. Right? It's all about those 6 magical ratios. They're not that magic, actually. They're pretty simple, really. So here then are the answers for those first 6 there on the front page. I've left them in fractional form, so if you converted to decimals, fantastic, great. Usually not necessary. Honestly, most of the time we'll be working with these in fractional form. That will be the most useful form because it retains the most useful information. You can see embedded within the fraction of sine of theta are those 2 sides of the triangle still right there in my numerator and denominator. The only time that disappears is on, say, like number 6. Down here, my tangent of theta is only 5/6. Well, that's because I had 10 over 12 and the fraction reduced. Okay? But seeing as these are ratios, we're generally going to keep them as fractions most of the time. I'm trying to think of a good context where you'll actually want the decimal version instead. I'm not really thinking of one. So only if the directions say so should you bother even turning it into a decimal. Unless it's something really simple, maybe 1/2. Turn it to 0.5. No, don't even do that. Leave it as 1/2. Okay. Any questions on these ones? Now it's even more extreme when I'm turning to look at the chat box there. You can always do voice. I've got the speaker running, so you can just shout things out to me. No questions here? All good? Okay. Do take special note of numbers 4 and 5, since these are our special triangles. This is good old 45, 45, 90, and we know that because it's the only right isosceles. If I've got 2 matching legs and the 90-degree angle in between them, it can only be the one and only right isosceles triangle, the 45, 45, 90. So this angle here is not mysterious. It's 45 degrees. And so we can quickly understand all of these ratios from our, remember that shortcut box had the list there. These are very common numbers, 1, root 2 over 2, and again, those are the 3 main ones. This simplifies to square root of 2, because when you rationalize the denominator. And number 5, look at that. Oh, I see something equals 1/2. If your sine or your cosine equals 1/2, you're dealing with a 30, 60, 90 triangle. In this case, the theta is the 60-degree angle. Okay, so that means this guy down here is the 30 degrees. That's why cosine is 1/2 and not sine is 1/2. Remember I said memorize sine of 30 degrees is 1/2. Okay? If you can get that one locked into your brain, you can work out the rest of them by matching them up. We'll talk more about that as we continue, various tools to help you remember the most common values here. Let's start with sine of 30 degrees is 1/2. All right, that's enough rambling from me. Moving on. Second page. Why don't you write an equation to find x, so the setup, and then actually go ahead and solve it. Okay? And it says round to the nearest tenth, so you should include 1 place after the decimal. Yes, even on 5, if it's said to the 10th, 5.0 is the correct answer. Don't just leave it as a 5. Please give us to the 10th so that we know that you know how accurate your answer truly is. Okay, and then 4 through 9, solving the triangle. And to solve a triangle means to find all of the measurements, 3 sides, 3 angles, all right there. So they start you off with 2 of them, really 3 of them actually, because we know it's a right triangle. So that's one of the angles already done, which means if they give you one angle, you just subtract that from 90 to get the other angle. And if they give you one side, okay, you're going to use your trig ratios, just like we did up here, to solve for the other 2 sides. So that's why in 4, 5, and 6, our 2 sides are all, I've got the double squiggles there. It's approximately equal to, because I have to round those answers, whereas the angles are exact. But in 7, 8, 9, they give us, no, sorry, just 7? 6 and 7, there we go. I knew it was a pair of them somewhere. 6 and 7, where they give us 2 sides, and we have to determine the other 2 angles. So those are approximate angles because I will have to solve for them using the inverse trigonometric button. Okay. Any questions there? No? All right, then just a quick preview of the other worksheet. Right, your practice worksheet will just be more of the same. So you've got find all 6 trig values. Remember, you really only need to find 3, and then you just invert them. Okay? Equation, using them to solve for x and solve the full triangle. And then the back page is more of the same, plus a quick little word problem here. Stands 150 meters from a water tower and sights to the top at an angle. It doesn't actually finish that. Let's make up an angle. How about we pick a number here? At an angle of, let's go with the classic, right? 42 degrees. Right? This is just like our activity we did yesterday, measuring the height of the flagpole or a tree or a building, something, right? A little practice there. So since that decided to cut off, and that's not even my, like, copying cut up, it's just That's the worksheet. All right, good job, Glencoe. Okay, well, there we go. I'm saying it's 42 degrees. Use that. All right, so with that, final call for questions before we begin the quizzes. No? All right, then we've got 16 questions about right triangle trig. Most of them will be conceptual there and a few actual calculations. So please go to joinmyquiz.com. Enter the game code 338517 to get started. And while you're doing that, I'm going to track down, see what happened from this worksheet. Joinmyquiz.com 338517. Pop, pop, there's 2. 3, 4. Five and 6. Okay, begin. Oh, their music is always way too loud. All right, and that will do it for the YouTube video for the folks that, in-person folks that are watching at home. The retake link, as always, will be posted at the end of class day, and it'll be open all week for you to practice with. 67, good start.